Differential equations, specifically linear equations with variable coefficients. Now this is a technique that's used to solve differential equations that are of this form. So if you have the form of y prime plus p of x times y is equal to q of x. Now you could have other variables here besides x. Some books have t's, so you'd have p of t, q of t over here. But if it's of this form, then you can use the methods that we're going to be taking a look at. So let's look at our steps. So solving a differential equation in the form of y prime plus p of x y is equal to q of x. Now step one is to write the problem in the right form. And I won't write down all the details of that, but you have to have y prime by itself. Now that could be dy over dx. You have to have the part that has a y in it over on the left side with something in front of it. And then over on the right side you'll have the rest then. So that's the form it has to be in. Okay, step two. Find the integration factor. I'll refer to as IF. And that's going to be equal to, let me put the symbol here. Let's see, object, Microsoft equation. And then we're going to have, yeah, assuming I can find my Greek symbol. There it is. Mu sub x is equal to e to the power of, and then the integral of p of x dx. Make that a little bit bigger now. Okay, so we want to find that factor. And now you're going to multiply both sides by the integration factor. Then step 4, recognize that the left side, and this is assuming the form I have up here, which means you have to have your y prime and this on this side. Recognize that the left side is the product property for derivatives, and write accordingly. Now it'll make more sense once we take a look at some problems. And then step 5, take the integral with respect to x for both sides. Okay, let's take a look at some problems then. Take a look. First problem here, we got y prime plus 5y is equal to x plus e to the negative 3x. Step 1. Write the problem in the right form. Well, it says that you have to have y prime by itself on the left side, nothing in front of it, so that's good. And you have to have the y part over here too, with whatever in front of it. That's good. And then all the rest on the right side. So this is in the right form. Now if I look at this form, whatever's in front of our y is our p. So this is going to be our p of x. Okay, Step 2, we want to find integration factor. And I'll do that over inside here. So this is step 2. And mu is going to be equal to this formula. Mu sub x is equal to e to the power of the integral of p of x, which was 5, dx. Well, the integral of constant, remember, you just put an x on it. So that'd be 5x. Now, we don't worry about putting a plus c on here because this is just an integration factor. And we're going to end up multiplying everything by it. We handle c later on. Step 3. Multiply both sides by the integration factor. So we're going to multiply both sides by e to the 5x. So I'll take e to the 5x times y prime plus 5y. And I'll take e to the 5x times x plus e to the negative 3x. Okay, over on this side, if I multiply that through, I'm going to have e to the 5x y prime plus e to the 5x times 5y gives us 5e to the 5x y. Now over on this side, if I multiply it through, e to the 5x times x gives us x e to the 5x. E to the 5x times e to the negative 3x. Since they're both e to a power, you add the exponents. 5x plus a negative 3x gives us 2x. So this is going to be e to the 2x. Okay. Step 4. Recognize that the left side, if the product, try it again, is the product, property for derivatives, and write accordingly. Well, you notice here, if I use them p's and q's, you might learn different variables. But if this is p, then this would be p prime. And if this was q, this will be q prime. Now, it'll always work out that way if you've done your integration factor correctly. This should always be the product property. So it shouldn't be like you wonder, well, does this time it works and this time it doesn't? It should always work. So I guess that's kind of a check to see if you did the integration factor correctly. Okay, well, which means that I could rewrite that as the derivative of p times q. So we got y e to the 5x equals x e to the 5x plus e to the 2x Step 5. Take the integral with respect to x for both sides. Okay, so I'm going to take the integral now. I'll take the integral of this derivative. And then I'll take the integral of this side. So we've got x e to the 5x plus e to the 2x dx. Now the integration and derivative are going to cancel each other away, and that leaves us y e to the 5x on this side. Now on this side I'm going to split this up. So I got the integral of x e to the 5x dx plus the integral of e to the 2x dx. Well, this one right here is going to be by parts, and this one will just be using our normal u substitution. Let's look at parts first. I'm going to use the shortcut with the table to find it. You choose one of these to be the derivative, one of them to be the integral. That's what the D and I stand for. The one that will disappear if you keep taking derivative is the one you should be a derivative, which should be x. If I put the derivative as e to the 5x, it will not disappear as I keep taking derivative. Well, the derivative of x is 1, and derivative of 1 is 0. Now our signs, I always starts with plus, minus, and then plus. And then the e to the 5x will be our integration. And if I take the integral of e to the 5x, that's again a u substitution. Let me just show it here real quick. Hopefully that's what you remembered. So u would equal to 5x, du would equal to 5dx, which means we need a 5 in here, so we put a 1/5 out in front. So then the integral of that actually becomes 1/5 e to the 5x. And if I did the integral again, same idea. It puts another 1/5 out in front, and 1/5 times 1/5 gives us 1/25 e to the 5x. Okay, now how this works is you go across like this, and then you go down like this. Then you go across like this, and you go down like this. So let's see what we have now. Okay, so we got y e to the 5x equals, and we'll look at this first part here. So I got a plus x times 1/5 e to the 5x. So that's going to be 1/5 x e to the 5x. So I'm just multiplying these together. Positive times the x times this. Okay, and then I take this times this times this. Well, negative times a 1, that's a negative 1, times a 1/25 e to the 5x gives us minus 1/25 e to the 5x. This one just drops away because when you do plus times 0, 0 times anything is 0. But then we have to throw our c on. Okay, now our goal is to get y by itself. So I'm going to divide both sides by e to the 5x. Oops, I forgot something, didn't I? Almost screwed up on the first one, the e to the 2x. Again, if I did a u substitution here, I let u equal 2x, then my du would be 2dx. I need a 2 inside, so I put a 1/2 out in front. So this would be 1/2 e to the 2x. And then I put my plus c on at the end. It's not a good sign when I about make a mistake on the first one. Now I want to get y by itself, so I divide everything by e to the 5x. And let's see, x e to the 5x over e to the 5x minus 1/25 times e to the 5x divided by e to the 5x plus 1/2 e to the 2x divided by e to the 5x plus c over e to the 5x. So I'm dividing everything by e to the 5x. Well, those are going to cancel, those will cancel, and those will cancel. So we got y is equal to 1 times x is x. We got x over 5, or 1/5 x, minus 1/25. And here, if you got e to a power over e to a power, you subtract the smaller exponent from the larger one. 5x minus 2x is 3x, so we're going to have e to the 3x where our larger exponent was, which is on the bottom. So this is plus 1 over 2e to the 3x, and plus c e to the 5x. Double check I didn't lose any numbers or anything there. Okay. So we got y is equal to 1/5 x minus 1/25 plus 1/2 e to the negative 3x. I move it up on top, sign of the exponent changes. Plus c e to the negative 5x. And that would be our answer to that problem. Okay, let me save that. Now let me clean this page off. And we'll take a look at our second example. I got 10 examples, and they're kind of all the same, with the same formula, but they're refreshing your memory on the different techniques for integration. So I guess if you feel good with all the different techniques and don't worry about watching all the examples, I figure it's a little bit better to have more examples than too few. Okay, so problem number 2. We got y prime minus 4y is equal to x squared e to the 4x. And in step 1. Actually, I guess on step 5 here, I should also say, and solve for y. It's kind of implied since we're trying to find the general solution, but then solve for y. Okay, well, the step 1, it's in the right form. We got y prime by itself, nothing in front of it. We got the y part over here with something in front of it, and then everything else over the other side. Now, based upon our form, the negative 4 is our p of x. Okay, step 2, find integration factor. So we got mu of x is equal e to the integral of p of x dx. So we got e to the integral, p of x we said was negative 4 dx, which would give us e to the negative 4x. Step 3, multiply both sides by the integration factor. So we're going to take e to the negative 4x times y prime minus 4y equals e to the negative 4x times x squared e to the positive 4x. Well, if I multiply that through, I'm going to get e to the negative 4x y prime minus 4 e to the negative 4x y equals, and over on this side, e to the negative 4x times e to the positive 4x. Since they're both e to a power, you add the exponents. Negative 4x plus 4x gives me 0, and e to the 0 is 1, so it drops away. And that just gives us x squared. Step 4. Recognize that the left side is a product property for derivatives and write accordingly. This would be our p. This would be our p prime. This would be q. And then derivative of that would be given by this. So this is q prime. So we can rewrite this as a derivative of y times e to the negative 4x. You're going to see a pattern on these. If you put it in, once you identify your p and q, p is always going to be y, no matter what. And then q will always be this first part right here, which will correspond to the first part right here, equals x squared. In step 5, we want to take the integral with respect to x for both sides and solve for y. So we'll take the integral of this derivative and we'll take the integral of this side. Well, over here they're going to cancel away, and that gives us y e to the negative 4x. And over on this side, remember when you have x to a power, you add 1 to your power divided by a new power. So that's going to be 1/3 x to the third plus c. Now we're solving for y, so we're going to divide both sides by e to the negative 4x because we don't get the y by itself. And over here, I'm going to go ahead and put the x to the third up on top, 3, and then I'll put the e to the negative 4x down here. And same with the c, I'll put the e to the negative 4x down here. Well, the e to the negative 4x's cancel. And we got y is equal to 1/3 x to the third. Now take that e to the negative 4x, move it up on top, and it becomes e to the positive 4x plus c I'll take that up on top and becomes e to the positive 4x. And that would be our answer. I don't think I got enough room for the next one. So I'm going to go ahead and save that. And then we'll clean off this page. And let's take a look at problem number 3. Okay, we got y prime plus 1 over x y equals 2 cosine of 4x. Step 1. Write the problem in the right form. Well, we have to have y prime by itself with nothing in front of it, so that's fine. The y part should be over here with something in front of it, and then everything else should be over here. So that's in the right form. Keep in mind the 1 over x is our p of x. Okay. So step 2, we want to find our integration factor using this formula. So we got mu of x is going to equal to e to the integral of p of x dx. So we're going to have e, and we just said that p of x is 1 over x. So we have the integral of 1 over x dx. Now the integral of 1 over x dx is natural log of x, like that. Now in this one, we can assume that we don't need to put absolute value bars on these. Even if I didn't put the requirements on here saying that we don't have to worry about it, you don't want to worry about it for these first problems here. So remember, e and natural log cancel each other out, so that simply gives us x. And that's our integration factor. Okay, step 3. We want to multiply both sides by the integration factor. So multiply both sides by x. So x times y prime plus 1 over x y equals x times 2 cosine 4x. So over here that gives us x y prime plus x times 1 over x cancels and just gives us y. But actually, more than that, it just gives us 1y. So keep that in mind. And then over here, if I multiply those through, I got 2x cosine of 4x. And step 4, recognize the left side as a product property for derivatives, write accordingly. Remember, y is always your p, and then this will be your p prime. This will always be your q, and then the derivative of x should be equal to this. So this would be your q prime. So that fits. That's kind of a check on the integration factor. So we can rewrite that as the derivative of p, which is y, times q, which is x, equals 2x cosine of 4x. Step 5. We want to take the integral with respect to x for both sides and solve for y. So we'll take the integral of this derivative with respect to x, and we'll take the integral of this side with respect to x. Well, over here this gives us yx, and over here this would be the parts again. So that's going to be by parts. Now I'm going to use my table. We can't always use a table, but if we can, then it makes it a lot easier. Remember, the derivative is going to be the part when you take derivative it disappears. Well, that has to be the 2x. Because the derivative of 2x is 2, and derivative of 2 is 0. Now cosine 4x will be our integration. And this will be the u substitution. If you let u equal to 4x, du will be 4 dx. We need a 1/4 out in front. So this becomes 1/4. And when we take the integral of cosine, then that gives us sine. Now to take the integral of this, that would be the u substitution again. We'd let u equal to 4x. So then du would be 4 dx, and we need another 1/4 out in front, so this becomes 1/16. Now the integral of sine is cosine. So this would be cosine 4x, but we have to add on a negative. Because remember, the integral of sine gives you cosine, but also gives you a negative. Okay, now our signs. This will be plus, minus, plus. So now I'm going to go crossways here and go down like that. And same thing here. So this we said that was yx equals, okay, a plus 2x times this. 2 times 1/4 gives us 2/4 or 1/2 x. So that's 1/2 x sine 4x. Then here I got a minus 2 times a negative, so negative times negative is positive. 2 times 1/16 is 2/16 or 1/8 cosine 4x. And then we have to throw our c on. Now some people may pull the 2 out in front there. I almost find this is easy to leave it in here because then I don't lose track of it as easy, but that's up to you. Now we want to solve for x, solve for y, so divide both sides by x. And here I'm going to put these on top. So I got x sine 4x over 2, and then we're dividing by x, so I put an x down there. Plus, I'll put the cosine 4x up on top. Got the 8 down here, and divide by x, so put an x down here. Plus, and then c divided by x. Now these x's cancel, and we got y equals, those x's cancel, and that gives us sine 4x divided by 2 plus cosine 4x divided by 8x plus c over x. And that would be our answer. Okay, let me save this. This is my first video dealing with differential equations, so I'm wondering how many little minor mistakes I'll make along the way. The theories sound what I'm doing, but you know, my forgetting a number, so forth when I integrate, but at least you get the idea. And am I erasing that? No, I'm not erasing that. Let's try it again. There we go. I find it easier just doing a undo to undo all that. When I start a new tablet, it kind of blows up every once in a while and crashes the tablet. Okay, so let's take a look at problem number 4. We got y prime minus 5y equals 4e to the x. Step 1, write the problem in the right form. Well, that's in the right form. We got y prime by itself, nothing in front of it, got the y over here, got the rest of it over here. So whatever's in front of a y then is going to be our p of x. Step 2 is to find our integration factor. Find an integration factor. So mu of x is going to equal to e to the power of integral of p of x dx, which is e to the integral of negative 5 dx. And remember, when you just have a number like that, you add an x onto it. So that becomes e to the negative 5x. Okay, so then we're going to multiply that times both sides. That's step 3. Multiply both sides by the integration factor. So we'll take e to the negative 5x times y prime minus 5y equals e to the negative 5x times 4e to the x. Over here, we got e to the negative 5x y prime minus 5e to the negative 5x y. And over on this side, the 4 is out in front. E to the negative 5x times e to the positive x. Since they're both e to a power, I'm going to add the exponents. Negative 5x plus x gives us e to the negative 4x. Step 4. Recognize that the left side is a product property for derivatives and write accordingly. Well, the y is always our p, the y prime is always our p prime. This will be our q, and if we did our integration factor right, the derivative of that should be equal to this. So that would be our q prime. So we can rewrite that as a derivative of p, which is y, times q, which is e to the negative 5x, equals 4e to the negative 4x. Step 5. Take the integral with respect to x for both sides and solve for y. So we got the integral of this derivative and then we got the integral of this one, 4e to the negative 4x dx. Over on the left side, those cancel and gives us ye to the negative 5x. Over on the right side, I can take that 4 and put it out in front, so I don't have to worry about it. Then integral of e to the negative 4x dx. This is a u substitution, so I'll let u equal to negative 4x du. The derivative of that will be negative 4 and then add on a dx. So we've got ye to the negative 5x equals 4. Now we're putting a negative 4 inside, so we have to offset it with a negative 1/4 out in front. You always put the reciprocal of this number out in front, because negative 1/4 times negative 4 would give us a positive 1, so we haven't really changed this value at all. And then the integral of negative 4e to the negative 4x dx. So we got e to the negative 5x equals, those 4's cancel and gives us a negative. And this I can rewrite then as e to the u du with our u substitution. So we've got ye to the negative 5x equals negative, the integral of e to the u is e to the u plus c. Now we need to plug our u back in. So we've got ye to the negative 5x equals negative e, and u up here we said was negative 4x, and then plus c. Okay, now we're going to solve for y, so we need to divide everything by e to the negative 5x. So we'll divide this by e to the negative 5x. And we'll divide the c by e to the negative 5x. Well, those are going to cancel there. Now, whenever you have negative exponents, you can take them opposite of where they're at in the fraction, and the sign of the exponent changes. So I'll take this, move it up on top, and I'll take the e to the negative 4x and move it on the bottom. Now, the negative that's up on top just stays there. So we got negative e to the positive 5x over e to the positive 4x. And then plus c, and then I'll take this e to the negative 5x up on top and it becomes e to the positive 5x. But out of space. Okay. Well, e to a power over e to a power. You subtract a smaller exponent from a larger one. 5x minus 4x is 1x, or x. So that gives us negative e to the x plus c e to the 5x. And that would be our answer. It's all assuming I don't make any mistakes on these. I don't work off of a script. I got these problems written down. Some of them I've worked ahead of time. Some of them I haven't worked at all. That's part of the fun of me creating these videos. Is the thrill of not working off of a script. Okay, so I'm gonna clean that off. Getting kind of thirsty. Let me grab a drink while that's cleaning off. That's bad. That pot's been sitting there a while. No fizz left to it at all, but I guess it won't kill me. Okay. Let's take a look at our next problem. Problem number 5. We got y prime plus 3y equals sine x. And it looks like I actually was smart enough to put a condition on the x on this one. Sometimes I don't see that until after I work the problem. I try not to steal problems unless I can steal them from differential equations books that are 100 years old where I won't be sued and copyright's gone. But okay. Step 1. Write the problem in the right form. Well, this isn't in the right form. We cannot have anything in front of our y prime. So step 1. First thing we'll do is we'll go through and divide everything by x. So divide that by x. Divide this by x, and then we'll divide sine x by x. So as x's cancel, we got y prime plus 3 over x, and then I'll put the y to the side, equals sine x over x. Now it's in the right form. We got y prime by itself, nothing in front of it. We got the y over here too with something in front of it, and then the rest of it over here on this side. Step 2. We want to find an integration factor. Now remember, whatever's in front of your y is going to be your p of x. So for integration factor, mu of x is going to equal to e to the power of the integral of p of x dx, which is e to the integral of 3 over x dx. Now the integral of the 3 can go out in front, so I'm not worried about it. But that would give us 3, and then the integral of 1 over x is natural log of x. Now from our properties, we know if we have a 3 out in front of our log, we can put it as a power. And then the e and the natural log are going to cancel, and so our integration factor is x to the third. Okay. So then step 3. Multiply both sides by integration factor. So I'm going to take x to the third times y prime plus 3 over x y equals x to the third times sine x over x. On this side, that gives us x to the third y prime plus x to the third times 3 over x. That x cancels one of these x's, and that leaves me 3x squared y. And over here, this x to the third cancels this x and leaves me x squared sine x. Step 4. Recognize that the left side is a product property for derivatives and write accordingly. The y is going to be our p, the y prime will be our p prime, the x to the third will be our q, and the 3x squared will be our q prime. And it would be. The derivative of x to the third is 3x squared. So that's a check to make sure you did the integration factor correctly. So we're going to rewrite this as a derivative of p, which was y, times q, which was x to the third, is going to equal to x squared sine x. Step 5. Take the integral with respect to x for both sides and solve for y. So we got the integral of this derivative, and then we got the integral over here. Now remember, these cancel each other, so that leaves us y x to the third on this side. Now over on this other side, we're going to use parts. And we're going to use our table again. So our sine, our derivative, and our integral. Okay, now derivative should be the part that when you keep taking derivative, it will disappear. If you keep taking derivative of sine x, it will not disappear. It bounces back and forth between cosine and sine. So x squared will be what I'll put here. Derivative of x squared is 2x. The derivative of 2x is 2. And derivative of 2 is 0. And this is plus, minus, plus, minus. Always starts with plus. Okay, and the sine x will be our integral. Well, the integral of sine x gives us negative cosine x. This negative is going to carry down, and then the integral of cosine gives us sine. And then the integral of this negative would carry down. The integral of sine gives us negative cosine. So that's going to give us a positive cosine. Okay, and this is how it flows. Always goes across for these first two and then down for the next one. And I don't think I have room to put it here, so let me skip down to here. And I got yx to the third equals positive x squared times negative cosine x gives us negative x squared cosine x. Then here we got a negative 2x times a negative sine x gives us a positive 2x sine x. And here's a positive 2 times a positive cosine, so that gives us a positive 2 cosine x plus c. That seems weird with sines, but yeah, I guess it does work out that way. Both those are positive. Now we need to solve for y, so we're going to divide everything by x to the third. There we go. Okay, so that gives us y. This x squared cancels with two of these, so that gives us negative cosine x over x. Plus, this x cancels with one of those, so that gives us 2 sine x over x squared. Plus 2 cosine x over x to the third. Plus c over x to the third. And that would be our answer. Let me save that. I guess that's problem number 5, wasn't it? So that'd be page 5. And let me clean this off. You see, I obviously have a very exciting life doing differential equations on a Saturday night. Okay, let's take a look at this one. We got y prime plus 3x squared y equals 3x squared e to the negative x to the third. Okay, let me get my fan going because I'm getting kind of warm in my little computer room here. There we go. Okay, step 1. Write the problem in the right form. Well, it isn't the right form. We got y prime here by itself. We got the part of the y over here, and then the rest of it over here. Now remember, whatever's in front of your y is going to be your p of x. So then for step 2, we want to find an integration factor. So mu of x is going to equal to e to the power of the integral of p of x dx. So we got e to the integral of 3x squared dx. Now if you got x to a power, you add 1 to your power, divide by new power. So it becomes x to the third over 3, and then those 3's cancel, so that just gives us x to the third. So that's the integration factor. Step 3. Multiply both sides by the integration factor. So we're going to take e to the x to the third, multiply times y prime plus 3x squared y equals e to the x to the third times 3x squared e to the negative x to the third. Now over here we got e x to the third y prime plus 3 e x to the third x squared y. Now let me rewrite that. Sorry. 3x squared e to the x to the third y. Now over on this side, we got e to a power times e to a power. X to the third plus negative x to the third gives me 0, so e to the 0 is 1, so it drops away. So we got 3x squared. Step 4. Recognize the left side as a product property for derivatives and write accordingly. This will be our P, this will be our P prime, this will be our Q, and all of this will be our Q prime. That's why I wanted those grouped together so we could easily see that. So I can rewrite that as a derivative of P, which is y, times Q, which is e to the x to the third, equals 3x squared. Step 5. Take the integral with respect to x for both sides and solve for y. Okay, so we got the integral of this derivative. And we got the integral of this side. Well, these cancel and gives us y e to the x to the third equals. Here we got x to a power, so I add 1 to my power divided by my new power. So we'd end up with 3x to the third over 3. This 3 here just carried down up on top. Then plus c, which gives us y e to the x to the third equals, those 3's cancel, I got x to the third plus c. Try and get y by itself, so we're going to divide everything by e to the x to the third. Now, it seems like most of the books that I looked at, when you're dealing with e to a power, they have no problem with e having a negative exponent. So I'm going to take that e to the negative, e to the positive x to the third up to the top, and it becomes e to the negative x to the third. And same thing here. Now they don't do that with anything else, but if you got e to a power, then they seem to have no problem with doing that. And that'd be our answer. So we'll print that. Okay, and I'm going to clean this page off. Let's take a look at number 7. We got 4y, or 4y prime plus y is equal to 5x. Step 1. Write the problem in the right form. Well, it's not in the right form. We got a number in front of our y prime. So first thing we're going to do is divide everything by 4. Divide that by 4, divide this by 4, and divide 5x by 4. So that gives us y prime plus, and I'll put the 1/4 out in front of the y because I like to have that separate, equals, and then 5/4 x. Now remember, if you have it in the correct form, then whatever's in front of your y is going to be your p of x. So step 2, we want to find our integration factor. So mu of x is going to equal to e to the power of the integral of p of x dx. So we got e to the integral of 1/4 dx. And remember, if you have a number, you just put an x on it. So it becomes e to the power of 1/4 x. And that's our integrating factor. Step 3. Multiply both sides by the integration factor. So we got e to the 1/4 x times y prime plus 1/4 y equals e to the 1/4 x times 5/4 x, which gives us e to the 1/4 x y prime plus, let me think how I want to write this, 1/4 e to the 1/4 x y. And on this side, I'm listening to my wife's message. Okay. Didn't sound like anything emergency, like I need a liver or anything like that. Recognize that the left side is the product property for derivatives and write accordingly. So this will be our P, and this will be our P prime. This will be our Q, oops, and then this will be our Q prime. And if you look at it, derivative of this does give you this. So that checks. So we can rewrite this as a derivative of P, which is y, times Q, which is e to the 1/4 x. And this is 5/4 x e to the 1/4 x. Step 5. Take the integral with respect to x for both sides and solve for y. So we've got the integral of this derivative dx, and then we got the integral of 5/4 x e to the 1/4 x dx. Well, on this side, this cancels away and leaves us y e to the 1/4 x equals, and this other side is going to be by parts again. And we can use our nice table for this. Sine, derivative, and integral. And the part that's going to disappear is the 5/4 x. Because the derivative of 5/4 x is 5/4, and then derivative of 5/4 is 0. The part you choose for the derivative should always end up going to 0 if you want to use a nice table. Okay. This is going to be a plus, minus, plus. Now e to the 1/4 x. If I take the integral of that, and I'm not going to show you all the steps, but if you do this over on the side, it's a u substitution. You let u equal to 1/4 x. du will be 1/4 dx, so you need a 1/4 inside the integral, so you put a 4 out in front. So this becomes actually e to the, or 4e to the 1/4 x. Now doing the u substitution again, we put another 4 out in front. 4 times 4 gives us 16 e to the 1/4 x. And again, how that works, we go across like that and then down, and then we go across and then we go down. And I don't know if I got enough room there. Maybe I do. Okay, so positive, and then 5/4 times 4, the 4's cancel, and that gives me 5x e to the 1/4 x. Now here I got negative 5/4 times 16. That gives us 20 e to the negative 1, or e to the positive 1/4 x plus c. I'm still thinking about my numbers here. Yeah, 20. And then e to the 1/4 x minus, okay, that all looks good. Now we're trying to get y by itself, so we're going to divide everything by e to the 1/4 x. So divide this by e to the 1/4 x minus 20e to the 1/4 x divided by e to the 1/4 x plus c over e to the 1/4 x. You know, those e to the 1/4 x's cancel there, 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 there. So we're going to end up with y is equal to 5x minus 20 plus c, e, and then I'll take that up on top, and it becomes a negative 1/4 x. And that would be our answer. So let me save that. Get some on page 7. And let me clean out the page. Okay, let's take a look at problem number 8. And I'll probably get too many examples here, but I do apologize for that if I do. I think this is the hideous one. Okay. I tried to pick one real hideous one so I could refresh your memory on a technique. And, okay, write problem in the right form. Well, y prime is by itself in the side, nothing in front of it. Y is over in this side too. Now, think about what number's in front of the y. That's an invisible 1. So this is going to be our p of x. So we don't need to do step 1, but step 2, we need to find an integration factor. So mu of x is going to equal to e to the integral of p of x dx. So we've got e to the integral of 1 dx, which simply gives us e to the x. Step 3. We want to multiply that times both sides. So we're going to have e to the x times y prime plus 1y equals e to the x times sine 2x. So that's going to give us e to the x y prime plus I guess just e to the x. I won't put the 1 there. Y equals e to the x sine 2x. Step 4. Recognize that the left side is a product rule. Our p will be our y will be our p, and y prime will be p prime. I'm watching Gran Torino. It's just a perfect episode, or perfect scene now. Okay, and that's our q prime. So it fits our form. So we'll take the derivative of p, which is y, and q, which is e to the x, and rewrite it that way. Step 5. Take the integral of both sides. And this just becomes y e to the x. Now on the right side, wait a minute. I didn't show the steps. We got the integral of the derivative. And then the integral of this. Okay, so this side here gives us y e to the x equals. And now to find the integral of this. Okay. Well, I'm going to continue step 5 probably on the next page if I had to guess. Let's just strictly look at this part right here. I can't use my my table. Table implies that your derivative is going to 0. But if I take derivative of e to the x, derivative of e to the x is e to the x, derivative of e to the x is e to the x, and goes on forever. The derivative of sine, on the other hand, is cosine, taking into account 2x also. And then derivative of cosine is negative sine, and then it just bounces back and forth. So nothing goes to 0. Okay, so here we're going to look at this right here. And I'll do it in blue, I guess, just so you know it's separate from this. And let me write that down. Y e to the x equals. On the next page, I'll complete this line I just started right here. But let's find the integral of this. E to the x sine of 2x dx. I'll switch over to black in case that's easier to see. And if you remember our formula for the integration by parts, it's going to allow us to not use a table, but we can, let me write up here. The integral of u dv is going to equal to uv minus the integral of v du. Okay. Well, the to figure out what our u and our dv is going to be, I suppose I should rewrite it. Okay, so we got the integral of sine 2x e to the x dx. This right here is going to be our u, and this right here is going to be our dv. It's always best to, if you got e involved, make that your dv. It just works out better, in my opinion. Okay. Well, in order to plug in our formula, we need u and v. Well, how we get v on this is well, let me clean that off. Trying to figure the best way to write this. Okay, let me put it up here. So we got the integral of sine 2x. These problems get really long, and I'm afraid my tablet isn't big enough to show it all. Dx. Okay, remember we said this was our u, and this was our dv. So that's our dv. Okay, so this part carries down. I'll start writing smaller in anticipation I'm not going to have enough room. Okay. And I need u. Well, u was sine 2x. So I'm going to go ahead and put that there. Sine 2x. I also need v. V is the integral of e to the x dx. Well, integral of e to the x dx is e to the x. Okay. And then minus the integral of v. Well, v is again the integral of this, which is e to the x. And then times du. Well, the derivative of sine is cosine, but then it's a chain rule. You have to take derivative of the 2x, which gives us 2 cosine 2x dx. Okay, now I'm going to rewrite that a little bit. So I got e to the x sine 2x dx equals e to the x sine 2x minus, and that 2 I'll bring out in front, and then I got the integral, and I'll put the cosine first, of 2x, and then ex dx. I'm going to apply the integration by parts again. This cosine 2x is going to be our u, and then the e to the x dx will be our dv. Okay, so we're going to have the integral of e to the x sine 2x dx equals e to the x sine 2x minus 2, and I'll put a bracket because this 2 has to be multiplied times everything that follows it. And now from our formula we need u, which is cosine 2x, and times v, and the integral of e to the x dx will give us v, so that's e to the x again, minus the integral of v, which was again e to the x, times du. Well, the derivative of cosine is negative sine, and since we have a 2x in there, we have to apply a chain rule, and so the derivative of 2x is 2, so this is really minus, wait a minute, where am I at? Okay, minus the integral of v and then du, so that'll be a negative sine 2x times 2 dx. Okay, again, the derivative of cosine is negative sine, then the 2x carries along. Chain rule, you have to multiply times 2, just like we did up here. I put it in front up here, but it was a chain rule. I should have put it after probably. Okay, so let's rewrite this a little bit. So we've got the integral of e to the x sine 2x dx is going to equal to e to the x sine 2x, and I'm going to multiply this 2 through, so that gives us negative 2, I'll put the e to the x first, cosine of 2x, all these signs here, I got negative here and negative here, that gives me a positive, and another negative out in front gives me a negative, then I got 2 times a 2, because I'm taking that 2 and putting it out in front, and then we got e to the x sine 2x dx. Okay, let me double check everything there. Negative, negative gives me a positive times another negative out, clear out in front. That gives me a negative. And then this 2 times this 2 gives me my 4, and I put it out in front. And I'm left with those. Okay, that looks good. Now notice something here. This left side that I keep carrying down happens to match this right here. So I can take this right here and move it over to the left side, treat it like a variable, and I'm going to end up with the integral of e to the x sine 2x dx. Now the negative 4 goes along with it, so it has to go along with it, and it becomes a positive 4 integral e to the x sine 2x dx equals, and then this remains. So I got e to the x sine 2x minus 2 e to the x cosine 2x. Well, we treat this like terms. You know, if we were to combine like terms, we add or subtract the numbers that are out in front. Well, same thing here. We got the invisible 1 here, and we got the 4 here, so that's going to give us 5. The integral of e to the x sine 2x dx equals the right side. So we have written everything down correctly. Now we're trying to get this integration by itself here, so I'll divide everything by 5. So the integral of e to the x sine 2x dx is going to equal to 1/5 e to the x sine 2x minus 2/5 e to the x cosine 2x. Wow. This right here, can't draw a box around it, but that right there, look at the left side. Integral of e to the x sine 2x. Notice what we were finding up here. What I put the box around. That's what we were trying to find. So we now can fill in this side right here. So y e to the x is going to equal to that right there. So y e to the x. Let's see, I wrote that down. Yeah, y to the e to the x is what it says, is equal to, then the right side here. So we got 1/5 e to the x sine 2x minus 2/5 e to the x cosine 2x. Now I didn't put it on there initially because I didn't want to confuse it. This is a tough integration by parts problem for a lot of students. But remember what we always have when you take the integral. We have our c in there, so we need to put our c on. Now we're trying to get y by itself, so we're going to divide everything by e to the x. So since I'm about out of room, maybe I'll just put it here. Divide both sides, or divide everything by e to the x. Then our answer is going to be y is equal to, those e to the x's cancel. So we've got 1/5 sine 2x minus, those e to the x's cancel. And we got 2/5 cosine 2x plus c e to the negative x. I take that and move it and put it up on top. And assuming no basic math error anywhere in that problem, that would be our answer. It's always questionable when I get into working those because my eyes cross and I don't get the numbers right or something. But the general principle of that is correct. I guess I should have this all separate, shouldn't I? Okay, that right there is just finding that integral. Okay, let me save this page. Okay, now I'm going to clean out the page. That was the hardest one we'll take a look at. Yes, I'm cleaning it off. Yes, I am. Okay, so let's take a look at our next one. Number 9. And we're getting close to the end. We've got 2 more examples after this. And I don't think any of these are as hard as that one we just looked at. That's the hardest one. Okay, step 1. Write the problem in the right form. It is in the right form. Y prime's by itself, nothing in front of it. Y's over here with it, and then the rest of it's over here. Remember, whatever number's in front of our y is going to be our p of x, which in this case is the invisible 1, so that's a negative 1. So we don't have to do step 1. Step 2, we want to find an integration factor. So mu of x is going to equal to e to the power of the integral of p of x dx. So that's an integral of e to the power of the integral of negative 1 dx equals e to the negative x. Step 3. Multiply both sides by integration factor. So we'll take e to the negative x times y prime minus y equals e to the negative x times 9x e to the 9x. Over here we got e to the negative x y prime minus e to the negative x y. And on this side, the 9x stays out in front. E to a power times e to a power, you add the exponents. Negative x plus 9x gives us e to the 8x. Step 4. Recognize that the left side is a product rule. This will be p, this will be p prime, this will be q, and then the negative e to the negative x is my q prime. So it works out. So I rewrite that as a derivative of p, which is y, times q, which is e to the negative x, equals 9x e to the 8x. Okay, step 5. Take the integral of both sides with respect to x. So we got the integral of the derivative And over here I got the integral of 9x e to the 8x dx. Well, over on this side, that's going to cancel. Gives us y e to the negative x equals. And we're going to use parts over here on the right side, but it's going to be the simple table one. Okay, so the part that would disappear with the derivative is 9x. Because the derivative of 9x is 9, derivative of 9 is 0. This is a plus minus plus. And the e to the 8x will be our integral. If you take the integral of that, you have to use u substitution. U would equal to 8x, so du would be 8 dx. So I need an 8 inside my integral, so I need 1/8 out in front. So I got 1/8 e to the 8x. Same thing here, I put another 1/8 out in front, and that gives us 1 over 64. 1/8 times 1/8, e to the 8x. Once you work with these enough, you see patterns on them, and you don't need to actually even show all the steps anymore. Okay, those two are going to go together, and I'll go down to there. Those two will go together, and that'll go down to there. So, we got positive 9x times this. That gives us 9/8 x e to the 8x minus 9 times 1/64 is 9/64 e to the 8x plus c. Okay. Now we want to get y by itself, so we'll divide both, or divide everything by e to the negative x. Let me put that in the right form. And then put e to the negative x here. Minus 9e to the 8x over 64, and I'm dividing by e to the negative x, so put that in the denominator. Plus c, and I'm dividing by e to the negative x, so put that in the denominator. Those cancel, and I got y. Now I take this e to the negative x, and I move it up on top, and the sign of the exponent is going to change on it. And same thing here, and same thing here. So this becomes 9x e to the 8x e to the positive x over 8 minus 9e to the 8x e to the positive x over 64 plus c e to the positive x. Well, e to a power times e to a power, you add the exponents. So we're going to have 9x e to the 9x over 8 minus 9e to the 9x over 64, same reasoning there, plus c e to the x. Now you could write those a little bit differently if you wanted to, but basically that's your answer. You could write as 9/8 x e to the 9x. Okay, let me save that. There we go. And we'll clean off that page. And let's take a look at problem number 10. We got y minus x sine x squared dx plus x dy is equal to 0. And this is not in the right form. It is really off. So let's do step 1 here. Step 1, we need to put it in this form. Now remember, another way of putting y prime is dy over dx. So I need dy over dx. So I'm going to go through and multiply or divide everything by dx to begin with. So I got y minus x sine x squared dx. I'll divide that by dx plus x dy dx is equal to 0 over dx. So that gives us y minus x sine x squared, those dx's cancel, plus x dy dx equals 0. Well, I need this first, so I'll rearrange it. I'll put this here. So I got x times dy dx. I'll put the y next, and then I'll take this negative x sine x squared to the right side, and it becomes a positive x sine x squared. It's getting closer. Remember, I need my derivative here, but nothing in front of it, so I'm going to need to go through and divide everything by x. Okay, so I'm going to have x times dy dx, divide by x, plus y over x is equal to x sine x squared over x. Those x's cancel, and I'm left with dy dx, but another way to write dy dx is y prime, plus 1 over x y. Those x's cancel, and I got sine of x squared. Now it's in the right form. Y prime's by itself, nothing in front of it. Y's over here, and then this side. So what's in front of our y is going to be our p of x. So step 2, we need to find an integrating factor. So mu of x is going to equal to e to the power of the integral of p of x dx, which is e to the integral of 1 over x dx, which is e, the integral of 1 over x dx is natural log of x. Now we're assuming that we don't need absolute value bars on this. I didn't specify it again on this problem, I don't think, but we just assume that's true. Excuse the fact I made some of these up and didn't put that on there. Actually, I stole this out of a book, and you'd be shocked how old the book was. It was 100 years old, or close to it. I think it was 1933 is where it came out of. Okay, e and natural log cancel, so that just gives us x. So we're going to multiply both sides by that. Step 3. So I'm going to take x times y prime plus 1 over xy is equal to x times sine x squared. That gives us xy prime plus x times 1 over x cancels, gives us 1 y equals x sine x squared. I had to think whether I needed the 1 there or not. Step 4. Recognize the left side as the product rule. This will be p, this will be p prime, this will be q, and derivative of x is 1, so that would be q prime. I did need the 1 there just to demonstrate that it fits that. So then I'll rewrite that as a derivative of p, which is y, times q, which is x, equals x sine x squared. Step 5. Take the integral of both sides. So I got the integral of this derivative and the integral of this. Over on the left side, those cancel and gives us yx. Over on the right side, this would be the u substitution. I let the x squared be u. So u is equal to x squared. Du would equal 2x dx, which means I need a 2 inside, and I'll offset it with a 1/2 out in front. So I got 1/2 there, and then I got 2x sine x squared dx. Now notice we now have 2x dx, which matches 2x dx, and the x squared here, of course, matches our x squared here. So I can rewrite that using the u substitution as 1/2 times the integral of sine u du. Well, the integral of sine is negative cosine, so that's going to be a negative cosine u. And I'll put my plus c on here at the end. Put the negative out in front, so I got negative 1/2 cosine. I plug my u back in. U is x squared. And then plus c. Now we want to get y by itself, so I divide everything by x. Divide by that by x, and here I'll put the cosine x squared up on top and 2 down below, and I'm dividing by x, so I'll put the x down there too. Plus c over x. Those x's cancel, and I got y is equal to negative cosine x squared over 2x plus c over x. And that would be our answer. Excuse me. Let me print that. Getting to the best part of Gran Torino, where he goes over and confronts them. They shoot him. They shoot him dead. But he does it to save his friend. So if you can get over some of the language in the movie, it's a good movie. I like to think that it can show that everybody can get along, even if you don't think you can initially. Okay. Enough of my soapbox. My dad used to always say it. He said people just in the world just talk to each other that realize that people are just people. He's right. X e to the negative 4x. In this one, we got y of 1 is equal to 0. Now this says find a solution of the given initial value problem. So we're going to start off doing the same technique here, but then we're going to apply this later on. Okay. Well, step 1. This is in the right form. So step 2. We want to find an integrating factor. So mu of x is going to equal to e to the power of the integral of p of x dx. So e to the power of the integral of 4 dx, which gives us e to the 4x. And that's what we're going to multiply by both sides. Step 3. So we got e to the 4x times y prime plus 4y equals e to the 4x times x e to the negative 4x. That gives us e to the 4x y prime plus, let me think how I want to write this, 4e to the 4x y. Now over here, e to the 4x times e to the negative 4x, e to the power times e to the power, you add the exponents. 4x minus 4x gives you 0, so we got e to the 0, which is 1. So that simply gives us an x over here. Step 4. Recognize it as product property. This will be p, that'll be p prime. This will be q, and then this would be q prime. So it fits. It works. So we rewrite that as derivative of p, which is y, times q, which is e to the 4x. It's equal to x. Step 5. Take the integral of both sides. So the integral of the derivative dx, and then the integral of x dx. So that gives us y e to the 4x equals the integral of x. You add 1 new power, divide by new power. So that gives us 1/2 x squared plus c. Now we're trying to get the y by itself, so we'll divide everything by e to the 4x. So we get y is equal to x squared over 2e to the 4x plus c over e to the 4x. Now over here on the side, I want to apply this initial condition. They're specifically telling us that x is equal to 1, and they're telling us y is equal to 0 with this notation. So we're going to go to this equation we just found, and we'll plug in these values. Put 0 in for y, put 1 in for x, 2e to the 4 times 1, plus c over e to the 4 times 1. If I multiply, well actually 1 squared is 1, 2e to the 4th, plus c e to the 4th. If I multiply everything by e to the fourth, then the e to the fourth is going to disappear, and we got 0 is equal to 1/2 plus c. Take the 1/2 over, it becomes a negative 1/2. And that's our c. And now we plug that back in. So this becomes y is equal to x squared over 2e to the 4x. I'll put the minus out in front. 1/2 over e to the 4x, or y is equal to x squared over 2e to the 4x minus 1 over 2e to the 4x. And that helps us to get rid of the c when you apply that condition. Well, that's the video. Hopefully I haven't made too many trivial mistakes in here, but I think you get the idea.